The world's most impressive mega projects are finally wrapping up in 2025. Towering skyscrapers, high-speed railways, and eco-friendly cities are redefining our future. These projects are built with cutting-edge technology, supported by billions, and showcase human ambition at its peak. Let's dive into the most impressive mega projects completing in 2025. The Grand Faw Port in Iraq is a massive infrastructure project aimed at positioning Iraq as a key player in global trade. Located in Basra province, the port will be one of the largest in the region upon completion, offering a strategic gateway for cargo movement between Europe, the Middle East, and Asia. The project features a 1,275-kilometer rail and road network designed to streamline the movement of goods between Europe and the Gulf region. It is anticipated to significantly reduce trade costs between China and Europe, with energy playing a crucial role due to the substantial oil reserves present in Iraq. The first phase of the Grand Faw Port includes 5 berths, which are nearly complete. It involves constructing breakwaters, container terminals, and storage facilities, essential for handling large volumes of goods. The project is set to feature modern port equipment, such as automated cranes and advanced container handling systems, to enhance efficiency and reduce operational costs. The project is part of the broader Development Road Initiative, with progress continuing steadily. The designs for the railway line and soil surveys for the development road have reached 100% completion, and the road construction is 84% finished. The Grand Faw Port construction employs some of the most powerful dredging and earth-moving machinery available. Large dredgers and excavators work to shape the deep-water channels in the port and foundations for container terminals. Modular construction techniques enable rapid development, particularly for storage and docking facilities. Advanced machinery and techniques are employed to ensure resilience against environmental challenges, such as strong winds and sandstorms. This $6 billion mega project on Al Faw Peninsula in Basra is planned to revolutionize the economy of Iraq. The foundation stone was laid on April 5, 2010. This strategic project is projected to have a capacity of 99 million tons annually, positioning it as one of the largest ports in the Gulf and the 10th largest worldwide. The Metro Jeddah project is a landmark initiative in Saudi Arabia aimed at improving urban mobility in Jeddah, the bustling coastal city of the kingdom. Part of Vision 2030, this project is expected to ease traffic congestion, reduce air pollution, and provide a modern public transportation system. The metro network, once complete, will span over 150 kilometers and consist of multiple lines connecting key districts, commercial areas, and residential zones. It will feature 4 lines, with a total of 113 kilometers of elevated double track, 44 kilometers of tunnels, 85 stations, and 5 depots. The project design incorporates smart city technology with fully automated trains, real-time data monitoring, and energy-efficient stations. Each station is equipped with eco-friendly features, including solar panels and advanced waste management systems. The Jeddah Metro will consist of 3 lines. The first line will run from Old Mecca Road to Sari Road. The second will run along Prince Majed Street from the site where the new Jeddah Airport is to be built, to the old airport. The third line will run along Palestine Road. For Metro Jeddah, advanced tunneling and construction machinery are essential to develop the underground sections of the network. TBMs are utilized to create deep tunnels with minimal surface disruption, especially near densely populated areas in Jeddah. To handle the sandy and coastal terrain of the city, custom TBMs with reinforced heads are used. Specialized machinery is also employed for installing elevated tracks, which include prefabricated concrete segments that are transported and assembled on site. Heavy-duty cranes and mobile track laying equipment facilitate rapid construction, allowing the project to meet its ambitious completion targets. The $11.9 billion project, initiated in 2013, is scheduled to open in phases from 2025 onward. Metro Jeddah will transform the mobility landscape of the city by offering a sustainable and convenient alternative to private cars. It will provide transport to 30% of commuters in Jeddah by 2040. With its advanced features, the metro will create a sustainable, resilient, and economically diverse city. The Guggenheim Abu Dhabi is a monumental museum project on Saadiyat Island, Abu Dhabi. This contemporary art museum is set to become one of the largest and most significant cultural institutions in the region. Designed by renowned architect Frank Gehry, the Guggenheim Abu Dhabi features a unique architectural style, with clusters of cuboid shapes and a dramatic central dome. This symbolizes Abu Dhabi's commitment to cultural innovation. Once completed, the Guggenheim Abu Dhabi will cover 42,000 square meters. It will stand 88 meters tall and will feature 9 cone-shaped structures, each of which will be a space for both commissions and acquisitions. The museum will house an extensive collection of modern and contemporary art from around the world, showcasing works from the Middle East, North Africa, and South Asia. Its design emphasizes sustainability, with a focus on natural ventilation, energy-efficient lighting, and solar power integration. The construction of the Guggenheim Abu Dhabi is a technical marvel, with materials like titanium and stainless steel incorporated into its structure to withstand the extreme climate in the region. High-powered cranes and steel cutters are used to shape the intricate titanium and stainless steel exterior. The prefabricated panels are carefully installed to maintain Gehry's iconic curves and angles. The construction also utilizes modular components to streamline the assembly of the complex internal spaces. Specialized cooling and insulation machinery ensure that the structure can withstand the extreme heat of Abu Dhabi. This museum's story started way back in 2006, and after lots of planning and building, it's almost here. Construction began in 2011 and paused for a bit, but now we know for sure it's coming in 2025, about 20 years after they first had the idea and 14 years after they started building it. When complete, this $1 billion cultural landmark will play a pivotal role in positioning Abu Dhabi as a global art destination, enhancing tourism and promoting cultural exchange. Faw Frankfurt is an ambitious high-rise project in the heart of Frankfurt, Germany. It consists of 4 skyscrapers, aiming to redefine urban living, workspaces, and leisure spaces. Designed by architectural firm UN Studio, the project merges residential, office, and retail spaces into a single, interconnected complex. The complex consists of 4 high-rise buildings, measuring heights of 233, 179, 128, and 104 meters respectively. The 4 towers are connected at the base by a multi-story plinth that forms the core of the new quarter. Here, the access routes to the city center and the surrounding districts will feature passages with retail outlets and gastronomic offers, such as a food hall. The city squares, with a special atmosphere, are created between the facades. And on the podium, a spacious roof terrace becomes a remarkable experience. The highest tower of the quartet touches the sky at a height of 233 meters. On its 55 floors, 4 office spaces will be created. The next tower, at 173 meters, will be one of the tallest residential skyscrapers in Germany. The second residential tower measures an impressive height as well, at 120 meters. In addition to a hotel, serviced apartments, and office space, approximately 600 apartments with direct visual contact with the weather and clouds will be built. Faw Frankfurt prioritizes sustainability with its use of energy-efficient systems and materials. The development incorporates green rooftops, optimized for urban farming, and rainwater recycling systems. Additionally, solar panels are integrated into the structure to generate renewable energy, supporting Frankfurt's push towards a greener future. The construction required a blend of traditional techniques and state-of-the-art construction technology to create a seamless and integrated design. Large cranes, high-powered concrete pumps, and advanced steel frameworks are employed to manage complex vertical structures and sky bridges. Each tower is built with reinforced concrete and steel, ensuring durability and structural integrity. The foundation work was extensive, requiring deep pile foundations to stabilize the skyscrapers in the dense urban area of Frankfurt. The use of prefabricated steel and glass facade panels accelerated the timeline while ensuring high-quality finishes. The estimated cost of the project is $1.065 billion, and the project is expected to be completed by 2025. This project adds a new dynamic to the real estate market in Frankfurt by offering high-end apartments, exclusive offices, and world-class retail spaces. By the time it's completed, Faw Frankfurt is set to become a premier lifestyle destination and a symbol of modern urban living in Germany. Project Apex, located in Hopkinsville, Kentucky, is shaping the future of sustainable EV battery production. The $3 billion Apex plant will produce battery materials on an industrial scale, powering up to 250,000 electric vehicles per year initially. Once fully operational in 2025, this capacity is expected to surge to 750,000 vehicles per year. The Apex plant operates on the hydro-to-cathode direct precursor synthesis process. This breakthrough technology enables the efficient recovery and reuse of battery-grade materials directly from recycled batteries. Unlike traditional methods, hydro-to-cathode minimizes chemical waste, reduces energy consumption, and cuts costs by 40%. Additionally, the plant will produce metal salts and precursor cathode materials, ensuring that the entire production cycle stays within US borders. To support its eco-friendly production, the Apex plant integrates advanced separation and refinement technologies. These systems efficiently extract and purify critical metals such as lithium, cobalt, and nickel, metals that are typically challenging and costly to mine. The facility uses closed-loop processing, which reuses water, reduces emissions, and minimizes waste. This approach makes Project Apex one of the greenest facilities in the US battery industry. Ascend Elements plans to invest close to $1 billion in the 140-acre campus and 500,000 square foot manufacturing facility. The first of its kind facility will be home to the company's innovative hydro-to-cathode direct precursor synthesis process technology. It's the most efficient and economically compelling way to return recycled battery materials to the battery supply chain. Soon, this facility will employ up to 400 people and generate up to $4.4 billion in economic impact to Kentucky over the construction period and first 10 years. The construction of the Apex facility is utilizing prefabricated modular units to accelerate the building timeline while maintaining quality. This approach enables efficient assembly of structural components on site, reducing construction waste and speeding up completion. Advanced robotics and automation equipment play a crucial role in optimizing material handling, reducing labor intensity, and ensuring precision at each construction stage. High-efficiency HVAC systems, renewable energy integration, and rainwater harvesting will further contribute to the sustainability goals of the plant. The Apex facility represents a landmark investment in green technology and clean energy. Scheduled for completion in 2025, it will not only enhance the EV market, but also strengthen the local economy, creating hundreds of jobs in Hopkinsville. Apex will follow the long-term strategy of Ascend Elements to produce 50 GWs of battery materials annually, enough to meet the needs of a rapidly growing EV market. Project Apex is indeed a pivotal step toward a sustainable, electrified future. Toyota Woven City is a groundbreaking smart city rising near Mount Fuji in Japan. Covering 175 acres, it aims to redefine urban living with eco-friendly designs and green technologies. Unlike traditional cities, Woven City has dedicated zones for autonomous vehicles, pedestrians, and eco-friendly transport like bikes and scooters. This unique layout ensures a smooth, safe flow of people and traffic, minimizing pollution and noise. With dedicated paths, Woven City promotes harmony between nature and technology, making it ideal for green living. This mega project will cover 708,000 square meters, built on the former site of Toyota's Higashi Fuji plant. This city will serve as a living laboratory where scientists, engineers, and residents work together to test sustainable technologies. It's essentially a prototype city where people, buildings, and vehicles are connected through smart technology. Key focus areas include robotics, AI, and smart homes that adapt to the needs of residents. Homes are powered by hydrogen fuel cells, a clean energy source that reduces emissions. Buildings are constructed using sustainable materials like wood, incorporating traditional Japanese design with modern architecture. Toyota has installed sensor networks throughout the city, creating a digital twin that constantly updates city functions. These sensors track energy consumption, air quality, and temperature, providing insights into energy conservation and environmental sustainability. Data analytics tools process information from several connected devices, enabling predictive maintenance, disaster management, and a highly responsive healthcare system. The city features e-pallet vehicles, Toyota's autonomous electric shuttles that transport residents, goods, and services across the city. Equipped with advanced sensors, cameras, and AI algorithms, these vehicles navigate safely and reduce the need for traditional cars, cutting down on emissions and congestion. Inside Woven City, robots play an essential role in daily operations and maintenance. Robots handle tasks like waste collection, package delivery, and cleaning, freeing residents from mundane chores. These robots are connected to a central control system, continuously gathering data to improve city operations. Using autonomous drones and rovers, Toyota is experimenting with new forms of urban mobility that make the city safer and more efficient. The construction of Woven City is a marvel in itself. Massive 3D printers, drones, and robotic cranes are used to assemble building components with precision, ensuring high standards of efficiency and safety. State-of-the-art tunneling machines have dug the underground infrastructure of the city, housing everything from utilities to hydrogen fuel cells. Robotic arms assist with high-rise construction, reducing labor costs and boosting productivity. Projected to cost a total of $10.13 billion, the city is expected to be operational by 2025. Toyota Woven City will be a place for co-creation, inventors, and residents who share their value and passion to invent something new for others. Initially, housing around 2,000 residents, Toyota employees, scientists, and their families, Woven City is designed as a collaborative environment for testing sustainable technologies. It's a living, breathing city designed not just for people to live in, but for the planet to thrive alongside. The Gordie Howe International Bridge is a cross-border project that connects Detroit, Michigan in the United States with Windsor, Ontario in Canada. This major infrastructure project is aimed at enhancing trade and transportation between the two countries by providing an additional crossing over the Detroit River. Named after hockey legend Gordie Howe, the bridge will span approximately 2.5 kilometers and feature 6 lanes, facilitating a steady flow of commercial and passenger traffic. Designed with cutting-edge engineering, the bridge is expected to be one of the longest cable-stayed bridges in North America. It is a 1.5-mile, 6-lane, cable-stayed crossing of the Detroit River, the 10th longest in the world. The bridge also includes a nearly 12-foot wide pedestrian and cycling path. Its construction includes innovative materials and techniques that ensure durability and efficiency, such as corrosion-resistant cables and anti-ice road surfaces. The Gordie Howe International Bridge project includes building new ports of entry. The new Canadian port of entry will be built on a 130-acre site and will be the largest Canadian port on the US-Canadian border. It will include inbound border inspection facilities for both passenger and commercial vehicles, outbound inspection facilities, toll collection facilities, a maintenance facility, and parking. Likewise, the US port of entry will be developed on a 167-acre site and will be one of the largest border facilities in North America. It will include inbound border inspection facilities for both passenger and commercial vehicles, together with outbound inspection facilities, commercial exit control booths, and parking. The construction of the Gordie Howe International Bridge involved specialized machinery, including cable-stayed bridge construction equipment and heavy lift cranes. Custom-designed cranes lift large steel trusses and facades. The advanced concrete pumping machinery is used to create durable foundations for the bridge's massive towers, which rise over 200 meters. The construction team is using advanced structural health monitoring systems to ensure quality and longevity throughout the building process. Engineers also deploy marine construction equipment as parts of the bridge span across the water. Started in 2018, this $5.7 billion project is expected to open to traffic in the fall of 2025. The bridge itself is expected to significantly reduce travel time between the two cities. It will alleviate the congestion on the Ambassador Bridge, which has been the primary crossing point for years. By facilitating trade and tourism, the Gordie Howe International Bridge will boost the economy on both sides of the border. It will support thousands of jobs and enhance North American supply chains at large. The Riyadh Metro is one of the largest urban transportation projects in Saudi Arabia. It is designed to revolutionize the way people travel across Riyadh, the capital of the kingdom. This $22.5 billion project consists of 6 metro lines, covering approximately 176 kilometers and featuring 85 stations. The ambitious project is part of Riyadh's development plan under Saudi Vision 2030, aiming to create a modern, sustainable, and efficient public transit network. The Riyadh Metro is the first railway project in the kingdom with underground tunnels, reaching depths between 20 and 35 meters. It operates on an automated system, controlled by central control rooms. The metro has a standardized design for its 338 train cars, giving it a distinctive appearance. The project will have 202 trains during operation, alongside 5 advanced centers for train movement management, control, and monitoring of trains, tracks, stations, and various project facilities. The Transportation Control Center, TCC, will be the centralized point for all customer contact. Using intelligent transport systems, it will coordinate the whole transport network. Each metro line will also have its own Technical Operational Control Center, OCC. The Riyadh Metro is divided into 6 lines with 6 globally agreed upon colors, facilitating the commuting process. These lines connect key areas across the city, including King Abdullah Financial District, King Khalid International Airport, major universities, the city center, and the public transport hub. The Riyadh Metro will serve approximately 1.2 million passengers, the intended capacity of this project at the start of operations. This number is expected to increase to 3.6 million passengers after 10 years. During its operation, the project also provides over 7,600 job opportunities annually, including 2,300 technical positions. Trains are fully automated, equipped with state-of-the-art safety systems, and designed to accommodate up to 400 passengers per train. The stations are designed with energy-efficient technologies, and integrate environmentally friendly materials. The metro carriages will be divided into 3 sections: first class, family class, and single class. The construction of the Riyadh Metro is a massive undertaking involving over 39,000 workers and advanced construction machinery. Specialized equipment, such as tunnel boring machines, is used to carve out underground passages, creating twin tunnels across the dense urban areas in the city. Each TBM is engineered to handle unique geological challenges posed by Riyadh, including hard rock layers. The construction involves extensive use of prefabricated tunnel segments and modular building components to streamline assembly and ensure precision. The project began in 2014, with a phased opening planned for 2024. However, it was later postponed to early 2025. The Riyadh Metro aims to find solutions for residents to navigate Riyadh, cutting down carbon emissions and relieving the notorious traffic congestion in the city. In addition, the comprehensive bus network will ensure last-mile connectivity, making public transport in Riyadh accessible, efficient, and convenient. The skyline of Dubai will soon welcome a new icon in 2025, called Ciel Tower, the tallest hotel in the world. Rising to 365 meters with 82 floors, this $500 million project redefines luxury and innovation in hospitality. Designed by London-based NORR Group, this architectural marvel is set to be completed in early 2025. Located in the prestigious Dubai Marina District, Ciel Tower offers breathtaking views of the city, Dubai Marina, and Palm Jumeirah. The Ciel Observatory deck on the 82nd floor provides a 360-degree panoramic view, ensuring guests enjoy a truly unforgettable experience. This sky-high oasis is designed to blend elegance with cutting-edge technology, setting a global benchmark for hotel architecture. The cold bent glass facade of the building is a striking feature, combining modern aesthetics with sustainability. The curved glass allows natural air circulation, enhancing energy efficiency throughout the structure. This careful design not only maximizes the views, but also reduces the environmental footprint. Vertical landscape terraces weave through the height of the tower, bringing green spaces and natural beauty to each floor. The unique structure of Ciel Tower has already earned it several awards, including the Best International Hotel Architecture Award at the 2019 International Property Awards. The bold shape of this tower, a sleek cylinder with an open center, creates a distinctive silhouette against the Dubai skyline. Ciel Tower is built to offer an unmatched luxury experience. With 1,042 suites, it provides a diverse range of accommodations, from luxurious suites to serviced apartments. Each suite features floor-to-ceiling windows, filling rooms with natural light and offering panoramic city views. The rooftop infinity pool on the 76th floor is a showstopper, allowing guests to swim with stunning views of the Arabian Gulf. For relaxation and wellness, Ciel Tower offers a spa and fitness center on the 54th floor. Guests can unwind while enjoying expansive views, making even a workout feel like a luxurious experience. The Sunset Lounge on the 74th floor provides the perfect spot to relax with a cocktail, watching Dubai's skyline glow in the evening light. At Ciel Tower, dining is as elevated as the view. Multiple high-end restaurants, including those on the rooftop, offer gourmet dining with spectacular city views. The Horizon Bar on the 76th floor and a variety of other culinary options cater to every taste, making dining an experience to remember. Constructing Ciel Tower required overcoming numerous challenges, including resource efficiency, sustainability, and wind resistance at such heights. Early in the design, computational fluid dynamics and wind tunnel modeling influenced the shape and structure of the building. These advanced techniques ensure Ciel Tower remains resilient against strong winds while maximizing structural efficiency. Dubai Marina, where Ciel Tower stands, is a vibrant area known for its high-rise buildings and canals. As the largest man-made marina globally, it's home to shopping malls, restaurants, and luxury accommodations, making it one of the most visited districts in Dubai. Ciel Tower will further elevate the status of Dubai Marina as a premier destination for leisure and luxury living. Sydney is on the verge of a transportation revolution. The Sydney Metro system promises faster, more efficient travel across the city. As the largest public transport project in Australia, this fully automated $21 billion driverless metro aims to transform commuting in Sydney. The Sydney Metro is designed to cover 66 kilometres with 31 stations. Its first stage, Sydney Metro Northwest, launched in 2019, running from Rouse Hill to Bankstown. From Sydenham, a second stage of the extension will convert a section of the existing Bankstown railway line to rapid transit standards. This addition will run through twin 15.5-kilometre tunnels under Sydney Harbour, the longest tunnels of their kind in Australia. This final extension is set to open in late 2025. The centrepiece of the metro network is Martin Place, a massive central hub linking key lines across Sydney. This central location is expected to significantly boost Sydney's economy by making it easier for people to travel for work and leisure. The 30-kilometre route from Castle Hill to Bankstown can be covered in just 35 minutes, making trips that once took hours feel almost instantaneous. By 2024, the metro aims to operate with a 98% on-time reliability rate and provide trains every 4 minutes during peak hours. Unlike traditional railways, the Sydney Metro won't rely on a fixed timetable. Passengers can simply turn up and expect a train within minutes. The Metro aims to handle 40,000 passengers an hour, nearly double the capacity of the existing suburban trains in Sydney, which manage 24,000 passengers. The benefits extend beyond convenience. The new Metro is expected to reduce traffic congestion on Sydney's busy roads, offering an alternative that will ease the notorious gridlock in the city. Additionally, the system is set to increase passenger capacity by 60%, allowing more people to travel quickly and efficiently throughout Sydney. Building the Sydney Metro is no small achievement. The construction involved 5,000 workers, including 400 specialised tunnellers and 5 powerful tunnel boring machines. One of these TBMs is an engineering marvel designed to tunnel beneath Sydney Harbour. Weighing 900 tonnes, this 120-metre-long machine operates with high-strength alloy discs on its cutting head. These are capable of breaking through the rock and carrying it away on a conveyor belt. As it moves, the TBM creates a circular tunnel lined with pre-constructed concrete segments. Each segment is carefully positioned using a vacuum lifting device, ensuring a seamless tunnel wall. The TBM then advances 1.7 metres and starts the process again. Underneath Sydney Harbour, the machine turns excavated rock into a slurry. This is pumped to the surface and transported by barges, minimising disruption to the bustling harbour above. The Sydney Metro will also offer advanced technology to support passengers. Real-time train information will be available at every station, accessible through a range of connected phone apps. These digital tools make planning trips easier, enabling riders to see when trains will arrive and monitor any service updates. The impact of the Sydney Metro system extends beyond travel time. Its creation supports Sydney's vision of a 30-minute city where people can reach work, schools, and essential services within half an hour. This metro system doesn't just connect locations, it connects communities, making Sydney a more accessible and dynamic city. With no need to wait for a timetable, people can move freely, efficiently, and reliably.